Hello everyone. So we are going to discuss function today, right? So some of the concepts related to functions. So let me tell you what is the index here. As you can see, we are going to discuss introduction first. I mean, what is function, definition of function, right? And then identification of function. How can we identify the function? Then we have some examples, right? On identification of function, and then methods for finding the domain. I mean, how can we find the domain of the function? And we'll take some examples on domain. Okay, so let us start the definition of the function, right? So see, suppose there are two sets, A and B, or non-empty set, we should say, right? So basically, function is a relation, and the relation should be following certain conditions, right? So what we can say, a function is a special type of relation. Function is a special type of relation defined from set A to set B, where both the sets are non-empty sets, right? Where all the elements of set A must be mapped with exactly one element in set B. That is the condition. So there should not be any case where single element, not a single element, is mapped with no element in set B or more than one element in set B, right? So let us take some examples. See, suppose, let me draw some mapping diagram. Okay, suppose we have two sets, A and B. Okay, these are the non-empty sets. These are the elements in set A and set B, right? Let me name them. Suppose this is A1, this is A2, this is A3, A4, this is B1, this is B2, this is B3, and this is B4. It is not necessary that, I mean, the cardinality of both the sets are equal, right? Okay. So suppose A1 is related to B3, A2 is related to, suppose, B2, and A3 is related to B4, and A4 is also related to B4, right? Now you can see we don't have to worry about the elements or the type of mapping is there in set B. So there is no condition for set B, right? So we have to see all the elements of set A are mapped with exactly one element in set B, right? So if you see A1, so A1 is mapped with B3, right? A2 is mapped with B2, and here A3 is mapped with B4, and A4 is also mapped with B4. So we don't see any violation of the condition. All the elements are mapped with exactly one element of set A to set B. Understood? Okay. So this is a function. No problem, right? Let me draw another diagram. Suppose, let me change the color. See here. Suppose we have set C and D. Suppose we have these elements. Okay. And here, let me show the mapping. This one, and this is also mapped. Now, if you see, this element in set C is unmapped, right? So this will not be a function because every element must be mapped with exactly one element. So this is not a function, right? Yes or no? Now, let me draw another diagram. Suppose we have E and F, relation defined from E to F. These are the elements here in E. These are the elements in F. Let me show you the mapping. Suppose this is mapped with this one, and this. Now, so for this element and this element and this element, we don't have any problem, right? Because these three elements are mapped with exactly one element in set F, right? But here, if you see, this element is mapped with two distinct elements, right? So this won't be a function. So I hope it is clear. So how can we identify whether the given relation is function or not? Okay, let us move ahead. Now there is one more thing by which, or one more concept by which we can identify the function graphically. The name of this concept is vertical line test. Okay, so what is vertical line test? You just draw the graph of a relation, in xy plane, and you just draw a vertical line which is basically parallel to y axis or perpendicular to x axis at any point, right? And if it cuts twice or more than once, then it will not be a function. Let me take some example. See, if you see the first example, if you take the first example, here this is the graph, right? Now what we have done, we have drawn a vertical line. Right? And you can clearly see it cuts the graph twice. So it means it is not a function. Similarly, over here, if you draw a vertical line, it cuts the graph more than once. So it means again this is not a function. But here, if you draw a vertical line, it cuts only once. So this is a function, right? Yes or no? Similarly, over here, it cuts only once. So it is not a function. Sorry, it is a function. My mistake. It is a function. Why? Because it cuts only once. So this is a function. Yes, understood. So there are two ways to identify whether the given relation is a function or not. One is mapping diagram. I have taken some examples. I hope you understood. And the next one, the next method is graphical method, by which we can identify whether the given relation is a function or not by using vertical line test. If it cuts more than once, then it is not a function, right? Okay. Let us move ahead. Okay. Now, so this is the method. These are the methods to find the domain of the function. How can we find the domain of the function? See, there are certain rules in mathematics, like in the denominator, it should not be 0. If anything is there in the denominator, it should not be 0, first thing. If we talk about real valued function, then inside the square root, whatever is there inside the square root, it should be non-negative. Yes or no? It means greater than or equal to 0. And suppose we have to find out the domain of two functions which are in addition, multiplication, or division, or subtraction. So what we need to do, we have to just find the domain of both the functions, and then we need to find out the intersection part of domain of both the functions. That will be effective domain, or the main domain of the function, or the domain of the function. Understood? And we have to make sure again, when two functions are in division, f of x by g of x, so we have to make sure g of x should not be 0. So these are certain rules to find out the domain of the function, right? Apart from special functions, these rules are sufficient to find out the domain of the function, right? And inequality you should know. So I expect that you already know how to solve the questions on inequality, right? So let us move ahead. So I hope you understood. Okay. Next, let us take some examples. Okay. So this is the first question that we are supposed to solve. We need to find out the domain of the function, which is under root 2 minus x minus 1 by under root 9 minus x square, right? So as you can see, we have two functions, we can say, yes or no? And both the functions are in subtraction, right? So what we can do, we can find out the domain separately for both the functions. And then what we can do, we can just find the intersection part, yes or no? So you will get the final answer. So let us try to find out the domain of the first part, right, of this function. So we have got, see, so we have got this under root 2 minus x, right? So as you can clearly see, this is inside the square root, so it should be greater than or equal to 0, right? And here, let me solve it over here. Since it is in the denominator and inside the square root, so what I can do here, 9 minus x square should be greater than 0 only. We can't take 0 because it is in the denominator, right? Now here it will be x is less than or equal to 2, very easy, right? And here what I can do, x square minus 9 less than or equal to 0. If you multiply by minus sign, then equality gets reversed, right? Now from here, if you solve, it is x plus 3 into x minus 3 less than 0. Using wavy curve or simple rule to find out the uh, value of x, right? Using the rule of inequality, you will get here, it will be from minus 3 to 3. So now we have got this here, we have got this, x is less than or equal to 2, and from the second part we have got x lies between minus 3 and 3. So what we have to do, we have to take the intersection of both the answers in order to find the final answer, right? So what you'll get, we can use the number line, right? So this is minus 3, this will be 3 here, and this is 2, right? So see, so this is less than 2, right, here, and this one, let me change the color here, from this is open interval, right? So we can't include minus 3 and 3. So what is the common reason? This is the common reason, right? This is the common reason. So minus 3 to which option? This is less than 2, and this is between minus 3 and 3. So what will get? Minus 3 to 2 open. Yes or no? So answer will be minus 3 to 2 close, we can say, right? So I think some options are wrong, but answer will be this. X belongs to minus 3 to 2 close. Okay. So let us move to the, I hope you understood. Let us move to the next question. Okay. We have to find out, just read the question carefully. This is the second question. The midpoint of domain of the function g of x is equal to under root 4 minus under root 2x plus 5. Very easy. What we can do? See, we have got two square roots, right? The first one, here, from this you can have 2x plus 5 greater than or equal to 0. And if you consider the whole square root, what will get? 4 minus 2x plus 5 inside the square root greater than or equal to 0, right? So we have to solve both the things. So let me solve the first part. Yeah. Yeah. So it is 2x plus 5 greater than or equal to 0. Now what will get? X is greater than or equal to minus 5 by 2. First thing, right? Now, so this is one of the answers. Now the second one, let me change the color. See, number 2, right? What we have got? 4 minus under root 2x plus 5 greater than or equal to 0. So what will get? 4 is greater than or equal to under root 2x plus 5. Yes. So now we can just squaring on both sides, what will get? 16 is 2x plus 5, and one more thing, should be always greater than or equal to 0. If you solve this, what will get? See here, 16 minus 5 is 11, is greater than or equal to 2x is greater than or equal to minus 5. So x, this will be 11 by 2 and minus 5. So what I can say? it is lying between minus 5 by 2 and 11 by 2, and here it should be greater than or equal to minus 5 by 2, right? So what we have to do, the final answer should be x belongs to minus 5 by 2 closed to 11 by 2. So this is the final answer, but what they are asking, see here, just a second, what they are asking, we have to find out, just a second. So we have got minus 5 by 2 to 11 by 2. Yeah. See. Yeah. So what we had got, x belongs to minus 5 by 2 to 11 by 2, right? This was the answer. Now what we have to do, we are supposed to find out the midpoint of domain of the function. So this is the domain. Now we are supposed to find out the midpoint of this. So what will get, minus 5 by 2 midpoint plus 11 by 2 upon 2. This is midpoint, right? So what will get, this is 11 minus 5 is 6 by 2, 3. So 3 by 2 will be final answer. So D is the final answer. I hope you got it, right? Very easy. Okay, next one. Let us move ahead. So this is the third question. See, very easy. So we have to find out the domain of the function f of x is equal to sine x minus 1 over x minus 1 into x plus 2, where this box denotes the greatest integer function less than x, right? So very easy. Let us solve it. So what we have, see, always remember whatever is there in the denominator, that should not be 0. I already told you, right? So what is there in the denominator? X minus 1, GIF of x minus 1 into GIF of x plus 2, that should not be 0. It means x minus 1, GIF of x minus 1 should not be 0, and x plus 2, GIF of x plus 2 should not be 0, right? So we already know where GIF function or greatest integer function becomes 0, when it is lying between 0 and 1, right? So let us see where it becomes 0, and then we have to just eliminate, or we have to just exclude those answers where the denominator becomes 0. So what we are trying to get for the values of x, and at what values of x denominator becomes 0. So x minus 1 lies between 0 and 1, and tell me, x plus 2 also lies between 0 and 1. Now if you solve this, what will get, this becomes 1 and this becomes 2. Here this becomes minus 2, and here it becomes minus 1, right? Yes. So x should not be lying between 1 and 2, and it should not lying between minus 2 and minus 1. Minus 2 and minus 1, right? So answer will be, so in these values of x, the denominator becomes 0, right? So x belongs to r minus, tell me, r minus 1 to 2, 1 to 2 union minus 2 to, sorry, here it should be open, right? So here 1, here 2 union minus 2 to minus, right? So C will be the right answer. I hope it is clear. Okay, next. Let us move to the next question, question number 4. So very easy question, very easy. See, we have to find out the domain of the function f of x is equal to under root minus log x minus 1 to the base 0.3 divided by under root x square plus 2x plus 8, right? So see, first of all, let us see whether denominator can become 0 or not ever, right? So what is there in the denominator? We have got x square plus 2x plus 8, right? It should not be 0, or we can say, what we can say, it should be greater than 0, right? So as you can see here, a is positive, and if you find out d is nothing but discriminant, b square minus 4ac. So d is negative, right? So if a is positive and d is negative, always remember the whole expression will always be positive, right? So the graph will be something like this. So for denominator, if you see, so we don't have any condition. I mean, you take any x, any real x, right? Denominator won't become neither 0 nor negative. So we don't have to worry about denominator here. Now let us discuss the numerator part. So it is already there, the square root, right, in the numerator. So whatever is there in the numerator, it should not be negative, right? So what I have to do should be positive, right? Now see, first of all, whatever is there in the log, inside the log, right, it should be positive. So what I can do, x minus 1 is greater than 0, so x is greater than 1. This is the first condition. Now we have to solve the main inequality, right here, main inequality. So if you multiply by minus sign, so it becomes 0.3. This is x minus 1 less than or equal to 0. So x minus 1 is less than or equal to, see, when you take anti-log and a is less than 1, the inequality gets reversed, right? So it will be like greater than or equal to 1. 0.3 raised to 0 is 1. So x is greater than or equal to 2. So if you take common, what will get? X is greater than 1 and x is greater than or equal to 2. Of course, the common part will be greater than or equal to 2. So the final answer will be from 2 to infinity, infinity open. So D will be the final answer. I hope you understood. Very easy. Let us move to the next question. Okay. See. So this is question number 5. So just read it carefully. Very easy. The domain of definition of the function, we have to find out log 2x square minus 7x plus 9 to the base x square minus x plus 1. Okay. So see, let us solve it. Very easy. See, always remember, if we have a function like log x base a, right? So there are 3 conditions which automatically come. So x should be greater than 0, a should be greater than 0, and a should not be equal to 1. Yes? Okay. Now, see, this is what our x is basically, right? This is what our x is here. This is x, right? And this is a. This is so a. So let us apply all these 3 conditions. Yes or no? So what we have to do? First condition, 2x square minus 7x plus 9 greater than 0. Let us solve it. So if you see, a is positive, and what is d? D is 49 minus, let us try to find out d, 49 minus 72, right, which is of course negative. Again, a is positive, d is negative, right? So the graph will be something like this. So it is always positive. You don't have to worry about the first condition. Now let us take the other condition, the second one. A is positive. What is a here? X square minus x plus 1, which is positive, right? It should be positive. So again here also, what is a? A is 1, which is positive, right? And what is d? D is again negative. If you find out d, you will get negative. Again, the graph of this expression will be something like this. Again, it is always positive. We don't have to worry about this one, right? So the second condition also satisfies for all values of x, all real values of x. Now let us try to find out the third condition. I mean, we have to apply the third condition. A should not be 1. So x square minus x plus 1 should not be equal to 1, right? So this 1 and this 1 will get cancelled. So x square minus x should not be 0, right? So I can take x common here. So you will get x into x minus 1 is equal to 0. So x is not equal to either 0 or 1. So I can take anything on any real values of x except 0 and 1. So answer will be C option, r minus 0 comma 1. I hope you understood, right? Okay. Let us move to the next question. Okay. Number 6. See here. So just read the question carefully. Find the domain of the function f of x is equal to under root sine x plus under root 16 minus x square, right? Okay. So let us solve it. Again, we have got two functions, right? We have got two functions. So what we have to do? We have to just find out the domain separately, right? So let us try to find out the domain of the second function first, right? So we have got 16 minus x square here. So 16 minus x square should be greater than or equal to 0, right? Because it is there in the square root, so it should not be negative. So if you multiply by minus sign, you will get x square minus 16 less than or equal to 0. If you factorize this, you will get x plus 4 into x minus 4 less than or equal to 0, right? So x belongs to minus 4 to 4. Minus 4 to 4. So this is what we have got. Here, if you just try to find out the condition for the first function, first part, right? So what will get? Sine x will be greater than or equal to 0, right? So let us try this question graphically. I mean this inequality, it becomes easier. So let us try to draw the graph of sine x. So this is the graph of sine x, right? Right. This is the graph of sine x. See here. So this is basically pi. This is 2 pi. This is minus pi. This is minus 2 pi, right? So what is approximate value? What is the approximate value of pi? It is 3.14, right? This is 6.28, right? And here this will be minus 3.14. This is nothing but minus 6.28, right? Yes or no? Now what is, see, from the second condition or from the second function, what we have got? X belongs to minus 4 to 4. So whatever the answer we are going to get, the final answer, it should be lying between minus 4 and 4 or from minus 4 to 4. Yes or no? It should not exceed this range, right? So see, minus 4 will be somewhere here and 4 will be somewhere here, right? Now we have to take positive, right? So this region will come, I mean this one, this is minus 4, right? And this is 4. So from minus 4 to minus pi, and this region is going to come, because here in this region it is positive. I mean sin x should be positive or greater than or equal to 0, I would say. And here also, right? So the final answer will be very easy. Minus 4 to minus pi union 0 to pi, right? So this will be the final answer. Understood? Okay. Let us move to the next example. I hope it is clear. Very easy. Okay. Now we have got this question number 7. See here. Find the domain of the function cos and root cos sin x plus sin inverse x square minus 1, right? So again we have to find the domain separately. So see here. cos sin x should be greater than or equal to 0. This is the first thing. And you mean to I mean to find the intersection part. So I have to write and, right? And here sine inverse x, what is the domain of sine inverse x? -1 to 1. So whatever is there inside the sine inverse, it should be lying from -1 to 1. So what will get? X square minus 1 should be lying between -1 and 1, right? Okay. See. So let us try to solve this one first, right? So always remember sine x always lies between -1 and 1, right? So it means you are going to get cos, inside the cos you are going to get -1 and 1, and which is nothing but it covers fourth quadrant and first quadrant from -1. This is nothing but radian, right? So approximately -57 degree to 57 degree, approximately, right? Approximately -57 degree to 57 degree, and it covers fourth quadrant and first quadrant where cos is positive. So we don't have to worry about the first condition. It is always true, right? For all x, for all real values of x. So no problem, right? Now here we have to solve this. So what we can do, we can solve them separately, right? If you take this one first, this one, what will get? And then we have to take this. So what will get? X square minus 1 must be greater than or equal to -1, and x square minus 1 must be less than or equal to 1. So you will get x square is greater than or equal to 0, which is always true. Don't have to worry about it. And then here you will get x square is less than or equal to 2. So x belongs to minus root 2 to root 2. So this is the final answer, right? So this is the final answer. Yeah, here x belongs to R we have got. Here x belongs to R we have got. So intersection, right? So intersection, I mean we have got R here from this condition and this condition, and here also we have got minus root 2 to root 2. So the final answer will be this, right? Okay. Next, let us move to the next question. So just read the question carefully. What is the question? Find the domain of the function f of x is equal to log base 4, and here also we have got log base 5 and log base 3, and this we have got 18x minus x square minus 77, right? So we have to find out the domain of this function. So see, although what we have to do, first of all, this log should be defined, right? This log should be defined here. This should be defined. If you consider as suppose k, right? So first of all, first condition will be k should be greater than 0. Then the second condition must be log base 3, here we have got k should be greater than 0. I mean this log, I'm talking about this log, right? I mean this one. And then the third condition will be log 5, I mean base 5, here 3 and here k. Here we have got 3 and here k should be greater than 0. So all these conditions must satisfy, right? Must be satisfied. So it may take a lot of time, right? But what you can do, if you solve this, I mean this should be greater than 0 for sure, right? So let us try to solve this. If you solve it, you may not be required, it may not be required to solve all the conditions. Let us check. So see, so what we have got, 18x, first of all 18x minus x square minus 77 must be greater than 0. So just multiply it by minus sign. So what will get? X square minus 18x plus 77, and the inequality gets reversed. Now if you see A is positive and D, if you try to find out D, it is of course negative. B square minus 4AC. What is B square? 324, and 4AC of course it will be more than 324, right? 77 into 4, right? So it will be more than 324, right? Yes or no? Let us check. Let us check. What is D? D is 18 square minus, no, it may not be negative. Just a second. Just a second. See, we can factorize it, I guess. Just a second. So I can write like x minus 11 into x minus 7. So D is not negative, my mistake. I thought D is negative. So x minus 11 and x minus 7 less than 0. So from here you will get x belongs to 7 to 11, right? Similarly, you can solve further conditions, right? Like this, I mean this one. So from here what you'll get, k is greater than 3, right? K is greater than 3. And from here what you can get, see, log k, if you solve this, you'll get log k base 3 is greater than 1 because 5 raised to, see, k is greater than 0 and here 3 raised to 0 is 1. My mistake. This should not be 3. This should be 3 raised to 0 is 1, right? Now here 5 raised to 0 is 1 and here k is greater than 3, right? So from here we are getting k is greater than 0. From here we are getting k is greater than 1 and from here we are getting k is greater than 3. So we don't have to take all these conditions, I mean this one and this one. What is the intersection part? If k is greater than 0, k is greater than 1. So here we are getting k is greater than 3. So what we can do, k is greater than 3, if you solve, whatever the answer you will get, that will be the final answer, right? So let us solve this. What is k? Is 18x minus x square minus 77 is greater than 3. So if you solve this, what will get? 18x minus x square minus 80 is greater than 0. So it will be like x square minus 18x plus 80 is less than 0. Now if we solve, if you factorize this, x minus 10, x minus 8 less than 0. So answer will be x belongs to 8. This is the final answer. I hope you understood. Okay, next. Okay, so the last question, question number 9. Please read it carefully. What is the question? Very easy. Find the domain of the function f of x is equal to x plus 1c to x minus 8, right? So as we all know, this is NCR, right? So what is the condition for NCR? If we have NCR, so always remember, first thing, N and R, all of them should belong to whole number, and R must be always less than or equal to N, and it should be greater than or equal to 0. So let us try to apply this condition, right? And remember, all of them should be whole numbers. Okay, so what is N here? So this is N basically here, and this is R. Yes or no? So 0 is less than or equal to, what is R? 2x minus 8, and here this is N, x plus 1. So let us solve this first, this one, and then we can solve this first, this second, right? Okay, so let us solve this one first. So this is nothing but 2x minus 8 is greater than or equal to 0. So x must be greater than or equal to 4, right? So this is the first condition we have got. Yes. Now here we can have 2x minus 8 less than or equal to x plus 1. So it will be x, 2x minus x becomes x, and here minus 8 plus 1. So all the whole numbers between 4 and 9, greater than 4 and less than 9, all the whole numbers, right? So we have to take only whole numbers. So x belongs to set containing 4, 5, 6, 7, 8 and 9. This is the final answer. We can check also, right? So this is the final answer. I hope you enjoyed the session. Let me revise quickly what we have covered so far. See, see here what we have covered so far. First of all, we have seen the definition of the function, right? That was the introduction part. What is function? How can we differentiate function and relation, right? And secondly, we have checked how can we identify the function. There were two methods, right? We discussed today. The first one using mapping diagram, and the second one was using the vertical line test. Okay, and then we have seen some examples. How can we identify the function using some diagrams, right? So some graph of the relation, right? And then we have seen how to find out the domain of general function, not special functions, right? For special function, there are certain rules that we have to see. And then we have seen some examples on domain. So that's it from my side for today's lecture. I hope you enjoyed the session. Thank you.